Good evening. My name is Yogarajan Analaki Subramaniam. My metric number 900803015171001. Subject EBTT3103 Innovation and Technology. Innovation and Technology. Given today's leading edge capabilities, it's reasonable to invention and prepare for data-driven factory of the future where all internal and external activities are connected through the same information platform. Customers, designers and operators will share information on everything from initial concepts to installation to performance feedback throughout the life cycle. Operators will assess materials on demand, collaborate with robots to use them safely and ergonomically, and rely on virtual work instructions presented at the point of use. Assembly lines will output highly personalized products, sometimes in a lot of size 1 that contain zero defects. Internet of Things (IoT), expanding the power of the web to link machines, sensors, computers, and humans in order to enable new levels of information monitoring, collection, processing, and analyzing. Provide more precision and can translate collected data into insights that, for example, help to determine the amount of voltage used to produce a product or to better understand how temperature, pressure, and humidity impact performance. To monitor the status of production lines in a real time via mobile devices and Wi-Fi RFID tags. Overall equipment effectiveness can increase by 24%, labor utilization by 10%, and throughput by 10% by adapting the IoT in a point. Real Real-time monitoring to connected information platforms that leverage data and advances analytics to deliver higher quality, more durable, and more reliable products. Enables connected devices to talk to each other, sending and receiving critical notifications. Results on reduced downtime, increased quality, reduced waste, and less overall cost. Robotics. Over the last decade, China emerged as a automated manufacturing powerhouse as increased labor costs and booming industrial demand drove tremendous growth in industrial robotics. Robots are employed to complement rather than replace workers. Cobotics is a well-known concept where operators and machines interact in order to make complex parts of the assembly process faster, easier, and safer. Cobotics is rapidly gaining momentum and successful implementations to date have focused largely on specific economically challenging tasks within the aerospace and automotive industries. More sophisticated sensors, adaptable, high functional robotics equipment is developed which allows interaction between humans and machines. 3D printing produces solid objects from digital designs by building out multiple layers of plastics, resin, or other materials in a precisely determined shape. To manufacture parts in small lots of product prototypes, to reduce design to manufacturing cycle times, and to dramatically alter the economics of production, is still in this infancy, and the technology is currently limited in the performance specifications of the products it can produce. This technology has evolved so much that it is now possible to produce almost any component using metal, plastic, mixed materials, and even human tissue. It has forced engineers and designers to think very differently when thinking about product development. Nanotechnology. It involves the manipulation of matter and atomic, molecular, and supramolecular scales, thus bringing with it super precision manufacturing. Currently applied mostly in space technology and biotechnology, in many ways it has already changed the world. This innovation can be advantage in variety of industries such as faster computer processing, smaller memory cards that have more memory space, clothes that last longer and keep the wearer cool in the summer, and bandages that heal wounds faster. In the future, there will be nanobots, microscope robots that will carry drugs to specific tissues in our body. Cloud computing, practice of using a network of internet connected remote services along various points of to store, manage and process data. Many companies are already using cloud computing and it has grows more stable and reliable. Used in manufacturing plants to spread out in various geographic areas in order to share data quickly and efficiently. Reduce costs, gain greater quality control, and increase the speed of production. Augmented reality. Recent advances in computer vision, computer science, information technology, and engineering have enabled manufacturers to deliver real time information and guidance of the point of use. These tools can be simultaneously assess the accuracy and timing of the task and notify the operator of quality risks. To provide hands-free training, enable faster responses to maintenance requests, track inventory, increase safety, and provide the real-time view of manufacturing operations. Involves using data and physical evidence retrieved by augmented reality on the factory floor to design new equipment that addresses the shortcomings of present-day devices on the assembly line. Challenges in implementing new technology, skill sets and experience. It was found that 75% of manufacturing components reported a shortage of skilled workers that required more than a high school diploma. As body boomers get older and retire, there's a growing need for people to replace them, but you cannot simply give people the skills needed to replace these jobs. Cost of a technology. Purchasing robots outright can be an expensive venture for large manufacturing companies. Cost of technology. To combat this, a new wave of companies are offering robotics as a service. The concept involves renting the robots for a decreased rate than simply buying them outright. In this way, companies can quickly and effectively implement robots into the workforce and still stay within budget. There are also companies who offer modular solutions which allow manufacturers to spend only what they need. Security, integrally tied to the components of Internet of Things IoT devices are the steps that researchers have taken to secure them. Anything of device that is controlled by network communication that faces the Internet is vulnerable to being hacked. To protect against these other threats, industrial enterprises should consider how they could integrate an advanced cyber threat protection solution into their network. Supply chain concerns. Cost and industrial reliability will also play a part as early adopter view to make the transition to IoT. To get ahead, this potential source of resistance organization must consider how they can best maximize transparency and standardization in the manufacturing process. Need to build devices according to an agreed upon standard that can be evaluated independently in an effort to confirm that only the expected hardware, software, and firmware is included. Safety relates to how the deep integration of connected devices are physically controls are introducing new methods of attack. There have been safely regulation for many years, of course, but they rarely consider how a logical attack might affect the physical result. Industrial enterprises can leverage the new collaboration channels between IT and OT to their advantage in response to that obstacle. IT security should start incorporating safety into the threat modeling and begin consulting with the OT security teams on how to do so. Conclusion. Innovative thinking has been round of mankind. At different times in history, events delivered approximately experiences that produce creativity in many forms. Occasionally, the most sudden occasion convey out the maximum progressive ideas. While human beings are driven to the brink like in times of problem, conflict, intense weather, or disasters, innovation flourishes. Maintaining competitiveness among these domestic and global challenges is a big issue for many